Hello, everybody. So today's session we should be able to move forward. The current issues that we're facing are the fact that I need to find a way to code the states of the player of an entity. So I'm going to compare what ChatGPT said and what I know so far about how to do this in an ECS system. So first of all, in the previous engine, let's see how I kept the state. So here's the player class. The player class is actually an actor, which is an entity. So previously I was using classic OOP inheritance. Now I'm using ECS. So I pre-registered when I lazy init this class, I instantiate a state manager, which is bound to this class, which is something like a queue. Yeah, it's like a queue of states. So you can push states into the entity. And I've noticed that I had some priorities here, which means that if you trigger something like jump, it had a higher priority than these. Like get hurt. So basically if the player gets hurt, the get hurt has more priority than walking, actually. And also it can interrupt the walking. So all good and dandy, but problem here is that the problem is that on each of these classes there is logic, like do respawn in case the player dies and so on. So that means that in ECS I cannot put this logic into a component because a component is just a dumb class. So that's exactly what I asked ChatGPT. So let's see what ChatGPT thinks about my question. My question was, I'm making a game engine in TypeScript with the help of a small ECS library that I made. I have full control over architecture of the game engine. Problem is that I have some player states which can do things at various ticks. An example being 200 ticks of idle state trigger a thinking state. This affects the animation of the character sprite. Same with the attack state. On frame 5 of the animation, the player inflicts a damage. The animation can be cancelled. The way I did this previously is that I created state classes like player walks state or player attack state, like I showed you here. All these. And in the And inside these classes, I kept the ticks and the update logic. Can I do this using components and systems? Problem that I have is that ECS components are dumb. They have no methods, only data. And systems deal with multiple entities, so that state cannot be kept on a system. I think this is the other question that I have. Can state be kept on a system? I don't think that the state should be kept on a system. I think state needs to be kept on an entity or a component of that entity. How should I keep the state given the above premises? And ChatGPT said, your understanding of ECS is correct. Components are typically dumb containers for data, and systems operate on multiple entities and their components. However, complex state management, like the scenario described with the player states, can still be handled with the ECS framework. Here's a strategy that aligns with ECS principles but also accommodates complex state logic. Using components for state data. Okay, and a follow-up question would be this. So the state cannot be kept. Using components as state data. State component creates a component that holds state data for an entity. This component should include a state identifier, idle, walking, attacking, a tick counter, and other relevant state data. Okay, so far so good. Okay. What? Okay. Using systems for state logic. Yeah, because once you have this into a component, now you're onto the system. State system implements a system that handles logic for state transitioning and update based on the data in the player state component. This system will check and update the state of each player entity on each tick. This I don't like. I mean, I don't necessarily like. Let's see. Implement a system that handles logic for state transition and updates based on the player state component. This system will check and update the state of each player entity on each tick. So player state system updates the entity, get component player and what ChatGPT misses here is that actually it doesn't miss this, because it's only the player state system. So you grab the state component, get the current state, and if it's idle, walking, attacking, it's interesting that ChatGPT didn't define player state, so it defined it like an enum. And then here, for each of the state, define the method. It seems cumbersome, but in the same time you don't allocate a new class for each state. So you just have these methods, and they can also interact with each other because they are in the same class. Although they look like static functions, if you see the input is already given, so they don't use any context. Okay. Kind of like this. I mean, having context here would be helpful, I think, so you don't call some functions many times. Let's see. Animation system interaction. Your animation system should work in tandem with the state system. It can read the current state and ticks from player state component to determine the correct animation frame. Okay, so then you have animation system, which updates the entity. Animation component, determine animation frame based. Okay. This makes sense. I mean, there's a lot of clutter here. But I think I have to see how this evolves. I like this. Benefits of this approach: maintain ECS principle, keeps the separation of data in components and logic in systems. Yeah. Allows complex state management while still being within the ECS framework. Each state's logic is encapsulated in the system, making the code more manageable and modular. By using components to store state data and systems to handle state logic, you can manage complex player states within the ECS architecture. This approach keeps the core ECS principles intact while providing the flexibility needed for intricate game mechanics. Remember that ECS is a pattern, not a strict rule. That's the limits that I'm exploring. So this is a... What the hell do I have here? Okay, never mind. Have some personal stuff there, but I don't know if those are important. So it says, remember, ECS pattern is a pattern. The ECS is a pattern, not a rule. Okay. System operator multiple. Okay, however, complex state management like scenario described. Here's a strategy, but also accommodate complex state logic. Okay, to me it's kind of clear what I need to do. And our current state is this. So the player now moves, although he moves too fast. The animation is too fast, but it moves. I'm actually curious of something. I'm always curious about performance. Performance monitor. So what I'm curious here is that with this system in place, do I have any memory leaks? I shouldn't have. I should have none. DOM nodes are fixed. JS events listen are fixed. I'm trying to think. Let me think about this. So when you move the entity, update state. Heap size. What is this? Okay, it doesn't look like something increases. I mean, I'm curious about the memory. Performance. Bam. Let's see. Moving the character. Stop. I kind of forgot how to work with this. Okay, screenshots, memory application. Interactions. These are the frames. Request animation frame. GPU. Call tree. I don't remember where you see the code. Memory. Obviously, I don't want to do anything right now, but like, I'm not looking for optimization. I'm just looking to see if I remember how this worked. Okay, so I can add throttling. I remember something about memory. Where was that? Memory Memory inspector. No. Performance. It didn't look like this. It was something with the seesaw, with the buzzes. Keep snapshot? Was it this one? No. Was like a buzz, so I don't see it here, so that means that I probably need to read some documentation on this. It's fine. We don't care about optimization right now. Okay, and with this in mind, we'll create a player state. Now I understand the state. So in the context, I want to understand something about rendering. In the context of rendering a small JavaScript game on canvas with 2D. Given the fact that I want to render a spreadsheet that contains some animation frames, I want to understand what does animation mean. In this context, because I think I need to start using keyframe as a convention. So it says that the keyframes are specific frames in an animation sequence that mark important points of action or transition. They define the start and end points of any smooth transition in the animation. Role in the animation. Keyframes are used as reference points. Animators or algorithms create in between frames called tweens. Not the case here. Sprite sheet is an image containing multiple graphics frames that are part of a larger animation, like a film strip. Using keyframes, when implementing keyframe animation, you select certain frames from the sprite sheet as keyframes. These frames represent significant points. Exactly. Okay. So back to our system, we have a player state component. Okay. I mean, calling this move with keyboard system is I think it's incorrect. I think I should start using some naming conventions like player, because it's related to the player. I mean, sure, you can have a keyboard bound to an entity, but then should I only call it keyboard system? No, let it like this, move with keyboard, or movement system. No, because movement system is I don't know how to call it at this point in time. BRB. back. Let's see. Where was I? Here. Need some music for the background. These are actually states, but they are animation states. I think I know. So this is state. TypeScript has a discrete enum type that allows various compile time checks and constraints. It would be extremely useful to allow generic constraints to be limited to enum types. Currently, the only way to do this is via t extend string or number. Oh my god, what a suggestion. Because you don't want to explicitly... Jesus Christ, no. Because I want to allow to be used at any enum type, correct. This is effectively what you want, though it will allow enum-like things, which is probably a feature. So type standard enum of t string t. This is a t extends type of Xazi. So this is not really enforce the must be enum constraint and only express the intent of having an enum through standard enum name. Would achieve just as much and be more succinct. So enum value. Okay, doesn't work, blah blah blah. think I got lost in the types. Until I don't do this, I have no idea. So this would be t extends enum, something like this. So I'm creating a state component which is abstract or general use, and then here you can put all types of enums. So let's say a player state, like here, player state, but it could be NPC state, whatever, enum, and these are enums. Let me go with the string. So this state animation state animation tick. Let's just go with this. Can't you just put a generic on a class? Yeah. Let's see. Animation state tick. Let me refactor this for a second. So okay, pre-render, good. Just what does this want? Oh, okay. So state. So basically this, I want them to be an enum. Tick, state tick, animation tick. State. Mr. Webpack died or not. Okay, so let me go back to the problem at hand. I just realized that this is actually the state of an animation. This is the name of the state. These are the keyframes. So I realized the proper naming conventions. And the other state is this, which is idle. And these should exist on the player. But how do you do it? How do you do this? That these are enums, so I don't mess up the I don't mess up the names. That's the only thing. That's why I want them enums. Otherwise, maybe I'm doing too much right now. Maybe I should have them as strings at the moment, and then somehow magically get these values in there instead of manually declaring them in an enum. TypeScript dynamic enum from JSON. You can't build an actual enum from object keys. You can get an union of keys, just key of type of. Yeah. Yeah. But I think this is a good exercise actually. So what if const player state player state const enum player state, and you have idle with what? Hi Cosmos, with what exactly? I'm using ChatGPT, but only to ask questions about stuff. I mean, I'm trying to learn how to do this. It's just bluntly using ChatGPT. It's not going to yield these results from the old engine that I had. I mean, there's a limitation to ChatGPT. You have to ask the proper questions, and if I don't have the vocabulary, it's kind of hard to know what to ask. I mean, I'm using it. And then there's player state and player animation state. And I'm going to do a manual thing here. in Sublime using the magic of multi-cursor. Okay. Oh shit, okay. Let me do something else then. Where's the regex here? Okay, name equal string is backslash w. No, backslash w is word. But I think it worked. Okay, find all, delete. And now remove this. State bound. Good. Oh shit, this is an enum. What the hell did I do? So copy this. And then I'll think about something automatic. But right now I don't care about that. So we have player state. This state, and let's see what happens when I put this here. So player state idle. It doesn't complain because it's string, but then when I'm going to use this, it's not going to work. I mean, I need to transform it into a generic type. Okay, and from arguing with ChatGPT over what should the system do as opposed to the old. So in the old engine, we had a state manager. Everything was OOP. So state manager, we pre-register all the states. Every state is a class. We have a priority. We still need that, by the way. I just realized shit. I just realized that these states here, when you register them, you should have also a priority. But I'm not gonna give them a priority right now. So yeah, in the old engine, we pre-register the state. The state contains a lot of logic, update logic and render logic. And from discussing with ChatGPT, it said that I should keep everything in a system in order to respect the ECS paradigm. So that's what I'm going to do right now. Among the systems here, I'll have a player state system. Although the ChatGPT recommendation, in my opinion, has a weakness where it says that the player state system should contain all the methods and the callbacks of that particular state, which will clog the code quite a bit. But again, let's see where this leads us. Our goal is to make the sprite animate slower, and that means that we have to have a mechanism to tell the state of walking to render the next keyframe only after the second tick or the third tick or whatever, however slow we want the movement animation to be. Okay, player state system. By the way, what's the speed of my 1 pixel? I'm curious, what if speed. We need to put this into a component, by the way. And just make a mental note on that. Speed 6. Speed 3. Yeah, it doesn't matter the speed in this case. It's just that the animation has to have the keyframes should be separated, like not one per 16 milliseconds, but maybe one each 2 ticks. So yeah, we're getting there. And also decouple this update state here. This update state should not be in the move keyboard system, I think. That's my impression of it. So that's why ChatGPT said, okay, you need a player state system. Okay. Just copy pasta some of the stuff. System. Oh my god, we still have the problem with the path. I'm gonna fix that at some point. Another improvement that I found is that right now I have the source maps working as expected. So the mistake that I was making is that even if I declared here a source map and it was inline source map, it doesn't matter. This was not needed, so the pre-processing of JS files was not needed. Instead, I needed to make TypeScript know that I'm going to emit source maps, and then all the everything started to be visible. Just a tip, if you don't put this here and just let's see, restart. So you're gonna have source maps, but they're going to be like this. You're not going to have the actual class name or whatever components. It's just Webpack. This is Webpack Mambo Jumbo. And although this works, I mean, you can put a breakpoint and you can say, oh, okay, this instance of direction and so on. It's just not accurate. So something that I've overlooked for quite a while and forgot about it. But now, if I want to debug, for example, here, it's very easy now. Have entity, direction from input, everything here, blah blah blah. F8, yeah, F8. Okay, back to player state system. So implement abstract classes. We need a query. We'll have a query. Constructor. Detected query. That's super. Don't need this. What? Oh shit, sorry. Okay. I guess it's unrelated to public. Protected query. Super. Then why the heck? Is it because this is not implemented or? What the hell? Oh shit, query. My bad. And now in the update here, we do const state. No, we do this query execute for each entity have the query. Okay, want me to type into, I'm gonna type into. And then we have entity get component state. And now we should have a switch. State, properties, state, case, player, state system, no player, state. Shit, if I define these here, I'm gonna create a circular dependency. So I will put them here in it's like a component stuff, player state. Yo, Neutron. What's happening, man? Player state, import player state, idle, break, default is idle, default. We'll see what we do here. And now we are encouraged to ChatGPT said move the update state so that means that I'm moving this from here well, I'm gonna move it to here. Wait, it's incorrect. Because walk. I think it's incorrect, but we'll see. Now I see it is not incorrect. It's okay. Protected. What would be a good naming convention for this? Update. Walk state. All right. So we previously had these. It makes sense. Protected update idle state. And then you have entity. Should you have entity or should you have something else? So if direction state bum bum bum, if it's not moving, But if you set the state idle here, and then in the next frame might work. This might work. So, because you are executing this in the same frame, you're setting idle up, do some stuff, and then here you catch up. You say, oh, okay, you set the state idle. Let me refresh everything. Let me start from scratch. Okay, I don't want to get confused. So is moving is not, doesn't have a purpose here. So this is like resetting the state. So you're setting and you're also resetting the state. So this is like coming from another state, like walking, to idle. And where this logic should exist. Is moving. So that's component. So I handled the movement here. And then if the player was not moving after all, I was updating the state. But you see, player not moving means that its state should be idle. So you need something like reset . Okay, this separation of concerns is really hard to grasp at the moment for me, because I had this tightly coupled in the states, in the states class. So previously, everything related to a state was in a class. Now, there is a separation of concern based on systems. This system only moves the entity. So it's like it moved or it didn't move. Should this be kept on state? Is moving. Because is moving is a dynamic action. But then you have this information. Okay, so who decides when a state is stopped? Because I had this concept previously. in the state manager, you could stop or trigger a state, like here. Entity state, trigger state, get hurt. So if dude is not moving, it's very important, then state needs to be reverted to idle. But how do you know it stopped moving? So is it either an event or either an intermediary state stopping, something like, and then the player state system says, ah, you're stopping. Okay. So if it's is moving or not, oh my god, so the player is moving, but then it stops. So it's no longer moving, but the state of it is still walking. Is it? Is it still walking? Who decides that it's no longer walking? You see, that's the part that ChatGPT missed here with its magic solution. Because you need to know when a state stopped. Because if you switch between states, you have to reset the state tick. So the tick is very important here. So there are two types of events here. One is that the system doesn't work because a player doesn't have a keyboard or the keys are not pressed. That means that it stopped. But on the next frame, this will issue is moving false as well. That doesn't mean that you need to reset to idle. So this system needs to simply not do its work. So how? So it all starts with the input, because the input has key press and key up, key down. So when the key is up, previously I was resetting the state, right? But you see, I reset it and always it was tick 0. That means the animation simply stayed. It didn't bounce up and down with the breathing. So in the old system, let me see something here, because in the old system I had this nailed down somehow. So I had a state manager, default state, states, current state item, queue. I had a queue of states. Ah, it's because the priority. Yes. Status actor finished. Holy shit, I had actor state not started, running, performing action, finished, running. Not sure about that. Running the state. The state was running, performing the action, finished. So what I did here is really good. Okay, let's ask, because I think I need a queue system. Christ. So basically a queue system. How did I knew that an animation stopped? Is this finished stuff? Actor finished. Okay. What? I had an exit. Okay, and but the walk had an exit as well. If player walks, else it exits the state. Yes, that makes sense. So I need this concept of exiting a state. It's interesting that exiting a state, like walking, should shut down the system, the walking system. Let's ask that ChatGPT. I'm having different states, like walking and idle. My problem with a system is that if I have a walking system, it will always execute and iterate. Always execute. Actually, that's not the problem. I have a working system who needs to transmit to signal that the walk has ended because the player is no longer pressing the walk bound keys. My problem with the system is that I have a walking system who needs to signal. How should I signal to other systems that walking state has ended? Actually, the question here is, how should I make the system not reset the tick? Let's see what this. Okay, this is something that I implemented. Walking key released. I don't agree with this. Okay, walking system can emit an end walk event. The animation system. State machine within component. Ha 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 ha. This is what I did. A finite state machine in a component. For more complex state management, consider implementing a state machine within your player state component. This state machine can manage transition between states. No shit. No shit. In my previous implementation, I used, but this seems not to respect the principles of ECS. Boom. You're recognizing that a state machine within a component can blur the lines of entity component system architecture principle in a pure ECS components. Should ideally be plain data, containers without logic, and system should handle the logic on the data within these components. However, practical implementation sometimes require balance between architectural purity and functionality, especially for complex features like state management. Adapting state machines to ECS. This is my thesis right now. So I need to put a state machine in the ECS. To better align with ECS principles while still running a state machine, you can externalize the state machine logic into a system. Okay, done. State component. Keep the player state component focused on data. Done. It can store the current relevant state, but it shouldn't contain the state machine logic. Oh. Then, oh my god, another system. Are you? Create a system that acts as a state machine. The system reads and updates based on logic and state transition, but this doesn't transition to walking. I think ChatGPT is hallucinating here. It wants me to put this on key down or on key up. What? That's the most stupid shit I ever seen. So I already solved this problem with the finite state machine, with the state manager, which has a queue, and you register the state, and then when you trigger, you trigger, but when you update, it says, okay, has it finished? Okay, if it hasn't finished and we have a current state, let's update it. If we have a queue, let's go to the queue. Okay, that's how you complicate simple stuff. Case player state walking, walk, break. Let me just follow the principles and see where it takes us. Idle entity. At least I have a little bit of experience with this, so I understand what the heck is happening. Because when you have a walking state, you're walking until you don't have a walking state. But then you have an idle state. But then you have to tell the system who is walking to no longer emit messages like, hey, I stop walking every frame. So that's why a finite state machine helps, because you can only have one state at a time and you have a queue of states, and each state, when it finishes the state, it says, okay, I finished. But now we have a system which only deals with walking and its state. And I believe that this can only be done with events. I believe you can only Nah, it doesn't make sense with the event. So if I put this here, update idle state, just idle, and I need the direction. In the primary direction that is currently set, I need the state. Wait, so I need the direction. Oh god, this is annoying. Direction. By the way, player state should be, it's fine. Direction. Okay. Oh shit, there's an implementation here. Fiat. Okay, and now cannot find player state. There's something interesting that's going to happen here. Is that the player will, I don't think it will ever, yeah. It doesn't animate. Let's see why is that. So move. So if he's moving, then I see now. So if it's moving, you have const state entity get state, and then you set the state to Thursday walk. Although you don't have keyframes here. I didn't activate the player state system. Jesus. Okay, so we need the state system player. State system. Right. So right. So we back to point 0 to where we started, but at least now we have a system that controls the state. So character is moving on screen. I see some jankiness there, but we'll get to that. It doesn't matter. Right, so we have the what if we have this? Okay, there's no idle left. So there's no signal that the dude has stopped. Because we don't have it here. And that's our original problem. Dude is walking, he stops. There's no way we know that he stopped. He stopped then, and he didn't actually. I remember how you can check this. It's with the future position. That's how you know he stopped. Holy shit, yeah. So was this a part of player walk state? So do walk means that it has reached a destination, calculate future position, blah blah blah, else exit. This exit I'm missing. That's the part that I'm missing. So who notifies? I got it, I got it. So you have to notify the player state system that you need to register a new event. So you queue, you say, okay, I stopped. Let's see something here. Console log. What is the current state? After all, because I think we need a default state basically. Idle and then walk. And we don't have a default state. We don't have a default state. That's why it doesn't work. Perfect. Perfect. Default state is idle. And we don't have an animation called idle right. Are you kidding me? Cannot find frame 5 for idle right. That's idle right. Frame 5. It doesn't have frame 5 indeed. Oh shit, is the parent. I forgot about this. Is the parent stuff. What was this? So idle right. I had a convention here. Because if you're idling right, I think this is a stupid convention actually. Idle right. I don't understand what parent is doing. And okay, and then we're back to resetting the state. That's what is happening here. Where is it? Rendering, move with keyboard. I don't update all state. Okay. So the problem is like this. Dude stopped and we somehow have to tell it that either right. Okay, either left. didn't have animations for this. Kind of strange. Where is the game? Kill mail, core, assets, sprites. Ah, right. So there's no idle left and right. It's just idle, which is front facing. Right, okay. It's fine. But I still need a finite state machine for this. Okay, the biggest problem right now is figuring out how to use a finite state machine inside an ECS. I mean, not inside an ECS, but along with ECS methodology. We're doing a lot of stuff right. But at this point in time, I'm kind of confused about how can I keep an individual how do I transition from one state to another? Who decides that? That's the question. Because if you walk and then you stop, who decides what you do next? The idling and the ticks and everything. But I think the mistake I'm doing right now, and let's do this really quick. I think the mistake that I'm doing is that I'm not adding another state. Let's just add the it left, it right. No, let's see other throw left, throw right. Wait a second, I don't have an animation for it left and it right. I'm a Dumbo. It left, it right, okay. There's no animation. Right, something else, something that we can quantify. Club up, club down. Okay, let's do this. Club. Let's do this pretty quick. So player club attack state. This is the old code. Player club attack state. What was the name of this? Club attack. This is the state, not the animation state, but the state. Player state. Okay, let's go with maybe I should move these out of here. Anyhow, club. Okay, club attack equals club attack, and then case player state club attack break. Another thing that ChatGPT missed. In a switch case scenario, you are bound to the order. So if you want to change the order, you have to change the code. Take that, ChatGPT. So my system was better. My finite state system was better than this. Club attack state entity state. We have a long road. And Cosmos said, why don't you use ChatGPT? ChatGPT doesn't know shit. I mean, it knows because it's based on the code that we wrote on GitHub and whatever. But it's still a dumb. It's a dumb. It's just a dumb machine that needs to learn these questions. And at the moment, ChatGPT doesn't know about subtleties. Like, actually, you know what? Please suggest how should I use a finite state machine that can queue states in an ECS powered game engine in JavaScript, in TypeScript, so we can have the types. So let's see. Components for state data. This violates the ECS. Sorry about that, ChatGPT. State machine logic in systems. That's fine. That's what we're doing right now. What? This might work. But it's very naive code. Other systems like state input animation can interact with state to queue new states and respond to the so the input system enqueues a state of walking. Again, very naive condition for walking, very naive code, very naive. So you mean you want to enqueue the state every time a player, every time the input system updates? You want to enqueue the state? You're gonna have a queue like your memory will blow up. No, so I think ChatGPT is hallucinating here. With all due respect. Let's see the club attack. Okay, I don't need to update this. Do I really need to update the state here? I just noticed this. It's just the animation that is changing, not the state. Right? Yeah. And now it stays. Okay. We don't have such states. Just have walk right, update walk state. Okay, so this is how I reset the state to idle by having a bug. So now it's actually manifesting it doesn't know where to end the state. Walk state. I know what I'm doing. Okay. I know exactly what goes wrong here. But I don't want to fix it right now. I want to understand the animation of another. I want to see this animation of club. So club 1, attack 1 up, down, left and right. And it all starts with the binding of the keys and input bind key. I guess space. Action 1. So space. What key is this? There's nothing here. There's no... What the heck? E key. What? Keyboard. No. Odd event listener. Empty space key. Ah, it's actually a space. Are you kidding me? This is a different question that I... This is actually a key. Space. Length. Are you kidding me? Yes, it's actually a space. Wow. That's kind of crazy. I mean, it makes sense. Okay, it makes sense. Okay, and now it's a space. Render system. What do we need here? We need another move with keyboard. No, actually, great. So now let's refactor this. It's time to refactor this. It's player keyboard system. And the rest died. I'm gonna refactor everything in a second. Where is it? Ah, it's refactored already. Player keyboard system. Okay. And here private hit with club. Just write some naive code here. We're gonna have state the entity club attack. Do club attack Just gonna call them like this. And do club attack entity. So you have this code if no keys are pressed. So if this input ongoing actions has input actions action 1, return false, else club attack. Okay, so on club attack, if everything works, should start animating this. But it doesn't. Clear state. Was it action 1 that I bound to this? Bind key space. Okay, let's try another key. Q. Okay. Time to put some player keyboard. Put some breakpoints here. Do club attack. Which one was it? Q. Okay, I got it with Q. Has component keywords. Our keyboard press has input ongoing actions. There are no ongoing actions. What? Why there are no ongoing actions? Why? Is bound key. Let's follow the journey. Is bound key Q? Yes. Oh shit, this is... Wait a second, I need this. Is bound key. Action. Add. Okay, add action. S1E5. Then the move system. Then execute and do this. And we got ongoing action 5. Right? And we got the player state with the club attack. Oh, got it. If this return, because if we do a club attack, then we need to exit the state. Okay. So we have different problems with the, I think with the state. And I don't think I'm able to do this right now. I need to set a clear goal for this. What I want to achieve by the end of the session. And right now I don't have a clear goal because I discovered that finite state machine needs to work in tandem with ECS. And at the moment it doesn't work because it doesn't know when to exit the state. So I need to add this concept of state. I think I need to bound it to the player, the entity. I need to bound it to the entity, but I'm thinking of having something special like get state. Just like I had in the old engine. With a queue, and these states operate on components, but it's just a matter of when you enter a state and when you exit, what happens. And that's the job of the state manager, which can be a system. There's no problem in that. But if I don't have this finite state machine, I don't have a cursivity between walking, hitting, jumping, whatever, and the animation follow this principle. They will not know when to stop, when to reset, when to whatever. So I think this is enough for me for today. Thank you for watching.